So the point of this one is actually to take each one of these numbers and put them in their categories. Okay? So -5, where does that belong? Integers is one place it belongs. It also belongs in...
Whole numbers.
Nope, whole numbers has to be zero. Rationals, yes. Real numbers. Okay, so we got -5 done. How about -1/7?
Rational.
That's going to be a rational. It's a fraction. And it's also a real. 0.
Whole.
Yes, it's a whole number.
Integer.
It's an integer.
Rational.
Yes, rational and real. Square root of 15. Square root of 15 is an irrational number. And it's a real. And then square root of 36. It's actually a natural number because the square root of 36 is 6, right? It's a whole number. It's an integer. It's a rational. And it's a real number. Okay? Now, for 2A, B, C, and D, what we need to do is actually state the property that belongs to those. So on this first one, what do we see? What happens? It's actually just distributing that 12 to both the 3 and the 6. So it's distributive. Okay? For B, what changes on B? Yeah, 81 is associating with 12 on the first part, and on the second part, he hangs out with 19. So this is associative property of addition. C. What's happening on this one? Yeah, so really only the 5 and the 13 are changing places. Okay? So this one's going to be commutative of addition. Or not addition, multiplication. And the last one, this one's commutative of addition. So for number 3, what we have to do here is just actually distribute that square root of 6. So that would be square root of 6 times 2 plus square root of 6 times square root of 6. And there's not much I can do with these two, so I'm just going to rewrite it like this.
6.
Yep. The second part's just a 6. So that's as far as I can take that. All right, so for properties of exponents, one thing you need to know is that the base of the exponent has to be the same in order for these rules to work. So, for instance, if I have 2 to the 3 times 2 to the 6th, notice that they both have a base of 2. Okay, so I can actually go through and add my exponents together here. So it would be 2 to the 3 plus 6, which is 2 to the 9th. Okay, but if I had 2 to the 3 times 3 to the 6th, that does not work. So I can't do that because they don't have the same base. Okay? So the power rule, we're going to actually take the same number. If I have 2 to the 3 to the 6th, that's the same thing as saying 2 to the 3 times 6, which is 2 to the 18th. Okay? And for the quotient rule, you're actually subtracting the exponents. So I'm going to have 2 to the 6th over 2 to the 3rd. I subtract that out, I have 2 to the third. Now, I just wanted to make a point here that you can also, if I were to flip these around where I have 2 to the third over 2 to the sixth, I can still subtract them, it's just that you're going to have a negative exponent. Okay, so it'll be 3 minus 6, or 2 to the negative third. Okay, so that still applies. Anything to the 0 power is a 1. Okay, so let's talk about negative exponents. What does that? Here we go. So notice that this is b to the negative m. So what happens is that really actually makes a reciprocal of it. So it'll be 1 over b to the m. So for example, if I have 3 to the negative 4, that'd be 1 over 3 to the 4th. It puts it underneath the fraction bar. So what would this one be?
1 over 8 to the
Yep, 1 over 8 to the second. Now this one's tricky. It's already underneath the fraction bar, so what do you think it's going to do?
9 thirds.
Yep, 9 to the third. So it's opposite of where it's at. If it's already underneath the fraction bar, it's going to move it back to the top. Okay? And then this one is going to be 1 over 19 to the first. Okay? So then we have powers of 10. A positive exponent on a 10 tells us how many zeros follow it. For example, if I have 10 to the 5th, how many zeros am I going to have after this 1? 5. 1, 2, 3, 4, 5. Okay? Negative exponent tells how many places there are to the right of the decimal. But I would also say it tells you how many zeros are in front of it. However, it looks a little different. So if I had 10 to the negative 5th, what I'm going to do is place 5 zeros in front of the 1. But I'm going to put a decimal after the first one. Okay? So that's really saying the same thing. It's how many places there are. This is like 1, 2, 3, 4, 5, including the 1. Or you can add a 0, but just make sure you put your decimal after the first 0. Okay, so in scientific notation, the first number that you're going to write down is always between 1 and 10. So for example, I have the number 2.3 times 10 to the third. That's in its correct form. However, if I wrote it like this, 0.23 times 10 to the fourth, that means the same thing, but that's not in its standard form, so we wouldn't write it that way because the decimal point's in front of the 2. And we wouldn't write it as 23 times 10 to the second. Those two numbers are exact same number as this, it's just that's not standard form because it needs to be between 1 and 10. So an example they give us here is in 2005, federal cost for Social Security was $519 billion. We need to express this in scientific notation. So first of all, let's write this out just as a billion. Okay? So we have thousands, millions, billions. Okay, so I need to set this up between a number of 1 and 10. So how do I write the first number? Yep, 5.19. So if I put my decimal right here, I need to count how many places are behind that decimal. So I know I have 3, 6, 9, 10, 11 places. So this will be to the 11th power. You use this a lot with science, sometimes with social studies when you're talking about populations, but a lot in science. The next one. Write 79,410,000,000 in scientific notation. So I would write this one as 7.941 because that's between 1 and 10 times 10, and I need to count how many places are behind this decimal point if I put the decimal here. So I got 3, 6, 9, 10. We did 10th power. On this one, notice it doesn't have a 0 in front of it, so I'm just going to add a 0 in front of it. Make sure that there's one there, because if you count zeros, you need to make sure there's one there. So this will be 1.9 times 10, and how many zeros do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll be to the negative 9th. Did I count that right? Okay. Okay, so on this one, we are going to add 6 places to this. We have a 1 already. That takes up one of the spots. Okay, so I'll have 1 and then add some zeros. 2, 3, 4, 5, 6. So you got to make sure you add 6 spots behind that 5. And then on this one, I want to add 7 zeros in front of the 7. 1, 2, 3, 4, 5, 6, 7, but I'm going to put a decimal point right here.